Hello, this is the lecture number 5 for the chapter sets, and in the last lecture we were discussing the exercise 1.3 and we have done up to question number 3. In question number 4 you have to find the subsets of the given sets. So you have to find the subset of this set containing only one element. Now because we know that the number of subset of a set is 2 raised to power n, where n is the number of elements. So first of all we find how many subset we can make of this set. So we have one element, so 2 raised to power 1 is equal to 2. So we have only two subset of this, which is empty, because empty set is a subset of every set, and the set containing the element A only. Now subset of AB. Now this set has two elements, so 2 raised to power 2, that is it will have four subsets which are empty set, A, B and AB, four subsets of this. Now the set containing element 1, 2, 3, the number of subset will be 2 raised to power 3, which is equal to 8, and they will be empty set. The set containing element 1, the set containing element 2, the set containing element 3, the set containing element 1, 2, the set containing element 1, 3, the set containing element 2, 3, and the set containing the element 1, 2, 3. The total 8 subsets of this set. We have the set empty set, and in this we have 0 element, so 2 raised to power 0 is 1, so it have only one subset which is empty. Now in question number 5 you have to find the power set of the empty set. So what is the power set? Power set is the subset of power set is the set of all subset of a set. So empty set, the number of subset we have already discussed is at only 1, and the power set of this empty set is we put in the curly bracket. So how many elements in this? It being asked how many elements the power set of this set has. It has only one element. In question number 6 you have to write the set builder form of the given convert the types of interval from roster form to set builder form, and from set builder form to the roster form. So see in your books, all of you, in question number 6 the class intervals are given in the set builder form, and you have to convert it into the roster form. Now in question number 6 it is a set builder form of the closed interval x such that x belongs to real number and x greater than -4 and less than equal to 6. So it means for -4 we should have open interval, and for 6 we should have a closed interval. So you have to write like this: open interval, for -4 it is open interval, for the closed interval it is 6. And similarly in the second part it is given that x is greater than -12 and less than -10, so we have open interval for both -12 and -10. In the third part it is given that x is greater and equal to 0 and less than 7. So because it is less than 7, so we have open interval, and because it is greater and equal to 0, so we have the closed interval here. See you on books, all of you. In the fourth part it is given that x is greater and equal to 3 and less and equal to 4. So we have the closed interval for both 3 as well as 4. The closed interval denotes the equal sign, that is given that x is greater than equal to 3 and less than equal to 4, that is from 3 to 4. Now in question number 7 the roster form of the interval is given, and it is given that -3 and 0 both lie in the open interval. So x is greater than -3 and less than 0. In this we have x greater than equal to 6 and less than equal to 12. In this we have x greater than 6 and less than equal to 12. And in this we have x greater than equal to -23 and less than 5. And as usual in the set builder form you have to write x such that x belongs to real number and such that. Now in question number 8 you have to find the universal set for the following: the set of right triangles. Now you have to give a set in which this set of triangles, right triangles, can lie, or is a subset of that set. Now because all the right triangles belongs to the triangle, so we can say that the universal set for this will be the set of all triangles. And similarly for the second part, the set of isosceles triangle we have, so the universal set for this can be the set of triangles, because isosceles triangles lie in the set of triangles. In question number 9, we have how many sets? We have set A containing the elements. We have 1, 3, 5, 2, 4, 6 set B. Set C has 0, 2, 4, 6, 8, and you have to decide from these sets which can be the universal set for these sets. Now, the set which contain all the elements of these three sets will be the universal set. So the C part containing all the element of these three sets, so we can say that the set containing the elements 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is the universal set for these three sets. Now we know that the universal set is a largest set of which all the sets are subset. So this is the exercise 1.3. Mostly they are very short questions and you can solve them orally. In exercise 1.3 also we have it is also a short exercise in which you have to find the union of the sets, or rather you have to find whether the given set is a subset of not. Now in exercise 1.4 you have to find the union of the given set. Now in question number 1, first part, the set X is given and the set Y is given. You have to find X union Y. You can very easily do it. Now in I'm taking the third part. Why I'm taking the third part? Because you have to find the union of these sets, and in the question number 5 you have to find the intersection of these sets also. So I'm doing the question number 5 and 1 at the same place. So first of all, question number 1, third part, convert this X is a natural number in the multiple of 3. So you first convert into the roster form, that is multiple of 3, 3, 6, 9, 12 and so on. And the set B is given as a natural number less than 6, which is 1, 2, 3, 4, 5. So you have to find the union of these sets. So you can easily find the union, that is the element which either belong in A or B. So 1, 2, 3, 4, 5, 6, 9, 12, 15 and so on. And in question number 5 you have to find the intersection of these. So intersection is common element of this, which is coming out to be 3 only. In fourth part, it is set builder form it is given, that is X is a natural number and X is greater than 1 and less than equal to 6. So greater than 1 it is 2, 3, 4, 5, 6 and less than equal to 6 means up to 6. In question number 8, it is given that a natural number is greater than 6 and less than 10. So 7, 8 and 9 are the natural number greater than 6 and less than 10. So you have to find the union. So it will be 2, 3, 4, 5, 6, 7, 8, 9. And the intersection of this is empty because it contains no element common to these two. In question number 1, fifth part, the set A containing the element 1, 2, 3. Set B is empty. So A union B is the total elements of A and B, or the which either belong in A or B. So it will be 1, 2 and 3. And the intersection will be empty because no element is common in this. Now in question number 2, it is given that the set A is containing the element AB and the set B containing the element ABC. So it being asked, see in your books all of you, it being asked whether A is a subset of B or not. Yes, A is a subset of B because all the element of set A, which is AB, belongs to the set B, which is containing the element ABC. So yes, A is a subset of B. Now if you find its union, so it is coming out to be ABC, so it is equal to B. So it means if A is a subset of B, then A union B is equal to B. The larger superset, it will be equal to, if A is a subset of B, then A union B will be equal to the superset or the larger set. Now if we find its intersection, it is coming out to be AB. See in your books question number 2. And we can conclude that if A is a subset of B, then A intersection B will be equal to the subset that is equal to A. This is the question number 2 as well as question number 3. In question number 4, the sets are given, set A, set B, set C and set D are given, and you have to find the unions of the sets. Question number 5 we have already discussed. In question number 6, The set A is given as 3, 5, 7, 9, 11. Set B is given as 7, 9, 11, 13. Set C is given 11, 13, 15, and D is given 15 and 17. I am taking its ninth part, in which you have to find A intersection B intersection B union C. So first of all, what you have to find? First of all, you have to find A intersection B. So A intersection B, find the common element of A and B, 7, 11. Then you have to find B union C. So B union C, total element of the sets B and C. So it is coming out to be 7, 9, 11, 13 and 15. And intersection sign is there. So it means you have to find the common element of these two, which is coming out to be 7 and 11. Which is coming out to be 7 and 11. So this is the way you have to do this question number 6, in which we have to find the union or intersection. In 7, the sets are given in the set builder form. That is, set A is given, see in your books, natural number. So natural number I have written 1, 2, 3, 4 and so on. Set B is given an even natural number. So I have written 2, 4, 6, 8 and so on. C is given as the odd natural number. So I have written 1, 3, 5 and so on. And D is given as the prime numbers. So I have written 2, 3, 5, 7, 11, 13 and so on. And in first part, you have to find A intersection B, which is coming out to be A intersection B. So it is coming out to be 2, 4, 6. If you find the common element of these, 2, 4, 6, 8 will be in this. The common element will be this, which is coming out to be B. If the question is given in the set builder form, you try to write the answer in the set builder form also. So like this, you can do the question number 7. In question number 8, you have to find which of the following are the disjoint sets. Now, I think we have not discussed the disjoint set. The disjoint sets are those sets in which we don't have any common element in those two sets, or if A intersection B is empty, then the two sets are said to be disjoint, or we can say that A and B are disjoint if A intersection B is equal to empty. So how can you do the question number 8? You find the intersection of the two given sets. If it is coming out to be empty, then it will be disjoint, otherwise they are not disjoint. Then the first part, A intersection B, is coming out to be 4, which is not equal to pi, so they are not disjoint. In question number 9, the sets are given. You have to find A minus B, B minus A. You know what is A minus B? Those elements which is A but not in B, and B minus A means those elements which are in B but not in A. In question number 10 also, you have to find the difference of the sets. In question number 11, R is a set of real number. Q is a rational number. So what is R minus Q? R minus Q means real number minus rational number. So you'll get the irrational number. So those elements which are in real number but not in rational number, so it will be a irrational number. In question number 12, you have to find whether the given two sets are disjoint or not. So how can you find whether they are disjoint or not? By finding their intersection. If the intersection is empty, then the sets are disjoint, otherwise they are not disjoint. Okay, thank you.